Hi, so for today we're going to talk about the exact differential equations part 2. This is a more challenging questions. Okay, and this can be a question in terms of quiz, okay, or in terms of problem sets, okay. So again, we if you may wish to recall, if we have a differential equation in terms like this, still m in terms of xy plus n in terms of xy dy equals 0, we can test for its exactness using this formula. And if they are equal, then that is an exact DE. Again, this is a partial of m, wherein this is our m with respect to y should equal to the partial derivative of n with respect to x. Okay, if they are equal, then that is an exact DE. And we will be using these formulas in order for us to get the solution to the exact DE. Of course, you have to get the r of x and the q of y also. Okay, so if you haven't watched my video all about the first part of this exact differential equation, I will be linking it below on the description, so you can watch this. Okay, you can also watch that. Okay, so let's get started. So let's have number one. So for number one, we have 2xy. We have 2xy minus tangent of y dx. Okay, plus x squared minus secant squared y multiplied by x. Okay, dy. So this x is not inside of the x secant squared y. Okay. So we have to get the partial of m with respect to y. So we have to differentiate this with respect to y. So any other variable other than y is considered as constant. So 2x is considered as constant. So we have 2x and the variable of y is 1. So we have 2x minus, okay, the derivative of tangent y is secant squared y. So now we have the partial of m with respect to x. This is our n. With respect to x, we have x squared, we have 2x, okay? Secant squared y is actually what? A constant because we are differentiating in terms of x. So the derivative of x would be simply 1. So that we have 2x minus secant squared y. And these two, 2x minus secant squared y, are equal, okay? Partial of m with respect to y equals partial of n with respect to x is checked. So therefore, this is an exact DE. Okay? So, what are we going to do next? We have this formula, partial of f with respect to x of mxy. So, we have 2xy minus tangent of y. Okay? Cross multiply, we have quantity 2xy minus tangent of y. Then we have dx. So, what are we going to do is to integrate, okay? Because f, upon integrating the left side, that is the function f, or f is the solution to the exact d. So, we have the integral of 2xy dx minus the integral of tangent of y dx. So, we are integrating in terms of x. So, the y is considered as constant, okay? So we can move it outside of the integral sign. So we have x dx minus, we have tangent of y, that is in terms of y, so that is a constant. So we have 2y multiplied by x squared all over 2. 2's will cancel. We have tangent of y, okay, tangent of y, and the derivative of dx is x plus, okay, a q of y constant. So any constant purely in terms containing purely in terms of y. Why? Because this is a substitute to the value of c. Okay, any value or term purely in terms of y is considered as constant. So that we have q of y. So we have x squared y minus x tangent of y plus q of y. So we need to get the value of q of y, and by also what? By also getting, okay, or performing this formula. So we have partial of f with respect to y of the n of xy. This is the n of xy. So we have x squared. So let me just rewrite this. This is minus x second squared y minus x second squared y. Okay, so if we cross multiply, we have x squared minus x second squared y. Then we have dy. Okay. And then integrate both sides of the equation. So we have f. That is the same f as this. Okay. So we have now integral of x squared dy minus integral of x secant squared y dy. So we are integrating in terms of y. So x would be considered as constant. So that we have x integral of secant squared y dy. So integrate. So we have x squared y minus the integral of secant squared is tangent of y. Okay? Plus, we have r of x. Okay? Any term r of x purely containing in terms of x. That r of x is a term purely containing in terms of x because that is considered as constant because we are integrating in terms of y. So we can equate these two. So we have x squared y minus x tangent of y plus r of x. Okay, to get the value of r of x and q of y. That is equivalent to this. X squared of y minus x tangent of y plus the q of y. And as you can see, x squared of y would be cancelled. We have minus x tan y. We have cancelled. So therefore, the value of r of x on the right side, is there any term purely containing in terms of x? No. So the value of r of x is 0. For q of y, here. So on the left side, do we have any terms containing in terms of y, purely in terms of y? No. So we have 0. So our answer could be derived from this f or this f. Okay? Simply replacing the f with the constant c. So therefore, our answer, since we have an rfx of 0, q of y of 0, it doesn't matter what f we need to choose. So we have x squared y minus x tangent of y, okay, equals, no, plus 0 because we know the value of rfx, q of y is 0, equals c. So we have replaced the f with c. Okay? So this is our answer for this problem. How about for number 2? So for number 2, we have sine theta minus 2r cosine squared theta. We have dr plus, we have 2r squared sine theta cosine theta plus r cosine theta, and we have t theta, okay, equals 0. So our variables change. In this case, we have r and theta. But we can think of r as x, dx, okay, as dx, dr as dx, and d theta as dy. Okay? So the test for exactness would be partial of m with respect to dy in our formula. So in this case, our dy will be d theta because we have a change in variable. Okay? So we're going to differentiate this in terms of theta. So sine theta would become cosine theta, okay, minus 2r. This 2r is considered as constant because we are differentiating in terms of theta. Okay, this 2r is considered as constant. So we have to differentiate cosine squared theta. And cosine squared theta, okay, if you may wish to recall, can be written as cosine theta squared. Okay? So if I get the derivative of this 2 cosine theta and then differentiate the cosine theta, so we have negative sine theta. Okay? So this is it. So we have 2 cosine of theta, 2 cosine of theta multiplied by negative sine theta. Okay? So simplifying, we have cosine of theta minus, okay, negative minus times this negative would be positive. So we have 2 times 2 would be 4r. No, so we have sine theta cosine theta. Okay? How about for the partial of m with respect to r? Okay? So we will be differentiating this n. So theta, all terms or all functions containing theta would be considered as constant. So 2r squared would be 4r by power rule and copy the sine theta cosine theta because again we are differentiating with respect to r plus cosine theta is constant here because differentiating with respect to r. So the derivative of r is 1. So that we have cosine theta. And this partial of m with respect to theta and the partial of n with respect to r are equal. So they are exact DE. So they are exact DE. So how do we solve? Okay, partial of f with respect to dr. Okay, so this is our x counterpart on our formula. So we have sine theta minus 2r squared cosine of theta. So we have partial of f. We have sine theta minus 2r squared cosine theta. Cosine squared. Okay. Cosine squared. That is not r squared, but cosine squared. Okay. Sorry for that correction. Okay. Then we have dr. So we are going to integrate both sides of our equation. Then we have f equals integral of sine theta dr minus integral of 2r cosine squared theta dr. So we are integrating with respect to r. So theta would be considered as constant, so we can factor it out outside of the integral sign. So we have cosine squared theta. We have, I can also factor out 2. So because that's a constant, so we have 2 integral of r dr here. So we have r sine theta, okay, minus 2 cosine squared theta. So we have r squared all over 2 plus, okay, q containing theta. Q theta, that would be our q of y. So any term, okay, any term here containing purely in terms of theta would be considered as constant. So these two will cancel so that we are left with an f of r sine theta, okay, minus r squared cosine squared theta plus q of theta. So how about the other one? We have the partial of n with respect to theta. Okay, so our n would be 2r squared sine theta cosine theta plus we have r cosine theta. Okay, so if I'm going to multiply it, this would become t theta. So I can now erase this. This is f, I mean. Okay. And we have to integrate. And upon integration, we all know what will happen. We have f equals the integral of 2r squared sine theta cosine theta t theta plus the integral of r cosine theta t theta. So we are integrating in terms of theta, so I can factor out r. Okay? So 2r squared sine theta cosine theta t theta plus we have r integral of cosine theta t theta. Okay, so I can let u equals cosine theta here. Du would be negative sine theta d theta. So I can multiply this in terms of negative 1 so that we have negative du equals sine theta d theta. So that's how we integrate. Okay, by u substitution. So we have 2r squared integral of u equal multiplied by negative du because sine theta d theta is equal to negative du. Okay. So plus we have r integral of cosine theta d theta. So how do we solve that? It's pretty easy. So we have 2r squared. Okay, I can factor out the negative. So this would become negative 2r squared. So we have u squared all over 2. Okay, plus r. The integral of cosine theta would be sine theta plus, okay, r in terms of small r. Okay, so because our variable is r. Okay, so any constant in terms of r. So negative 2 divided by 2 would be negative r squared u squared plus we have r sine theta plus r of r. So u squared or u is equal to cosine. So we have negative r squared cosine squared theta plus r sine theta plus big R of r. And then now we are going to equate this f and our first f to get the value of q of theta and r of r. So we have, first we have r sine of theta here minus r squared cosine squared theta plus q of theta equals, we have r sine of theta minus r squared cosine squared theta plus r of r. And as you can see, okay, r sine theta cancel. Okay, so q of theta, since there are no, on the right side, there are no term containing purely in terms of theta, so this would become 0. Okay, and r of r, okay, since on the left side of the equation, there are no variable in terms of purely in terms of r, so that would be 0. So our answer again would be still r sine theta minus r squared cosine squared theta equals the value C. Okay? On the right side of our solution. For our last problem for this video, I think. So you have for number 3, you have y e raised to xy minus 2y cubed of dx plus x e raised to xy minus 6xy squared minus 2y, we have dy equals 0. Okay? So test for exactness first. So we have to get the partial of m with respect to y. So let me just rewrite this. Y e raised to xy minus 2y cubed. So x would be considered as a constant. Okay? So this y e raised to xy, this term contains both y. So we have to perform product rule. So first, I copy the first one, this y. Okay, I differentiate this with respect to y, e raised to xy. So if I differentiate it with respect to y, I am considering x as constant. So my derivative would be x e raised to xy. Okay, so that is just like e raised to 2x and the 2 is the x. Okay, so if we get the derivative of e raised to 2x, so that is 2e 2x. Okay, so x here is considered as the 2, the constant. So I have an x here. Plus, copy the second one and differentiate the y, that is 1. Minus, with respect to y, we have 6, okay, y squared. So simplify. So you have xy e raised to xy plus e raised to xy minus 6y squared. Partial of n with respect to x. So that is x e raised to xy minus 6xy squared minus 2y. So partial derivative with respect to x. This is again product rule because this both has x. So we have x. Okay. The y here would be considered as constant. So we have y e raised to xy. Okay. Plus, copy the second one. We have e raised to xy multiplied by the derivative of x, which is 1. Okay. Minus, with respect to x, so this would be 6y squared because the derivative of x is simply 1 minus 0 because 2y is considered as constant when we are differentiating with respect to x. So we have xy e raised to xy plus e raised to xy minus 6y squared. Okay, and as you can see, these two are equal. So therefore, they are an exact DE. Okay, so we perform the function of f. I would just multiply the dx already here on the right side. So we have y e raised to xy minus 2y cubed. We have the dx here. So we integrate both sides of the equation so that we have now f equals integral of y e raised to xy. We have dx, okay, minus minus 2y cubed. Okay? Integral of 2y cubed dx. So we are integrating with respect to x, so I can factor out y, e raised to xy dx. So we have minus 2y cubed integral of dx. So we can think of y here, because we are integrating in terms of x, we can think of y here as our constant. Okay, when we integrate e raised to xy. Okay, so when we integrate this again, okay, y is considered as constant. So that is just like integral of e raised to 2x, where our 2 is equivalent to y. So how do we integrate this? This is 1 half e raised to 2x. We know that plus c. Okay, because we get the derivative of this u, 2x, and then we have du, we have 2 dx, so that we have du all over 2 equals dx, so that we get that 1 half. So the same principle will apply here. So this would be y all over, multiplied by 1 all over, okay, y here, then we have e raised to xy, minus we have 2xy cubed plus q of y. Okay? So this would cancel, so that we have e raised to xy, e raised to xy minus 2xy cubed plus q of y for our first f. Okay? So for the second one, we have partial of f with respect equals x e raised to xy minus 6xy squared, this term, minus 2y, and then we have dy. So I can integrate them both sides of the equation, so that we have now f equals the integral of x e raised to xy dy minus integral of 6xy squared dy minus the integral of 2y dy. So we are integrating with respect to y, so I can factor out x. We have we have e raised to xy. I'm so sorry for that. So that would be e raised to xy dy minus, okay, 6x integral of y squared dy minus 2 integral of y dy. Okay, I continue here. So what will happen is that we have x. Since we are integrating with respect to y, x is considered as constant. So we have 1 over x, okay, multiplied by e raised to xy, minus, we have 6x y cubed all over 3, okay, minus 2y squared all over 2. This is a square, okay, plus we have r of x. So this cancels. So this would be 2. Okay, this also cancels. So we have e raised to xy minus 2xy cubed minus y squared plus r of x. So this is our another solution for f. So we equate them. So first, this is our f. So we equate those two. We have e raised to xy minus 2xy. Okay. 2xy cubed plus q of y to determine the value of q of y and r of x. So we have this e raised to xy minus 2xy cubed minus y squared plus r of x. Okay? So as you can see, we can determine the values of q of y and r of x. So we have q of y. The value of q of y would be negative y squared, because this is the term on the other side of the equation containing purely in terms of y. And r of x, do we see anything here? None. Okay? None. So, the answer, okay, we can pick an answer, okay, by fulfilling or using the values of q of y or r of x. So, in this case, since r of x is 0, so this must be the answer. Okay? So it would be easier if I'm going to use this f. So we have e raised to xy minus 2xy cubed minus y squared plus r of x, which is 0, equals c. Okay, so you can also use the other one just as long as you add the q of y. Okay. So, again, if you learned something from this video, thank you so much. Please don't forget to subscribe to my channel. So, I hope you learned something, okay, all about the exact differential equations. And again, thank you so much for listening. This is Engineer Abat. God bless you all.